So, what we began in the previous class is a topic which closes the Keynesian model description. Earlier, we did a simple Keynesian model called Keynesian cross model, then we did the ISLM model. But the ISLM model considers only the demand function. It has a very simple supply function, so it ignores the complications of the supply market, of the supply side. And so we now going to go through this medium run model, variable price Keynesian model, which will allow price to change. And what we started doing is developing the supply function, the Keynesian supply function. Now, as before, the supply function considers essentially two things. One, the description of the production function, how output is produced using one factor of production, the simple situation we have called labor. Capital is held constant, it's not going to change, that we assumed. That means not going to change with changing levels of varying levels of output or employment. Capital is going to fix, like this classroom. The number of chairs, fans, lights are not going to change with number of students I teach. So I can begin a story by saying there is one student, then two students, three students, four students, keep on adding, and what happens to something, whatever output we are producing. And in this production function, we assumed also that the properties of the production function are well defined. The marginal product, the first derivative is positive, marginal product of labor, Fn. Second derivative of the production function, which is slope of the marginal product curve, Fnn, is negative. That means diminishing marginal productivity of labor is assumed. As you hire more people, as a company or as the country employs more people, the output, extra output that you get from the extra labor that you hire is going to get smaller and smaller as you keep on hiring people. It's positive, it's contributing something extra. When I'm hired, I contribute something, but what I contribute will be more than when the next person is hired. His contribution is less than mine. So these are technological features of a production function, technical aspects, why that happens. And we talk about those things in details in microeconomics. If you open a microeconomics book, you will see they explain why diminishing marginal productivity is there. And after having defined the production function, I went into the labor market, just the way I did in the classical model. In the labor market, there will be a labor demand function and a labor supply function. Now, in the Keynesian model, we have lots of complications. First, the good news is the labor demand function is the same, the labor demand function we had in the classical model, which is Fn is equal to W over P, which I wrote by rearranging terms Pfn is equal to W. There is a reason why I did that. But when we came to the labor supply function, I assumed something called money illusion. That is, people work by looking at the money wage they get, 10,000 rupees or 20,000 rupees. They don't consider how much they can buy with that money. this kind of an assumption is there if you look at the labor supply function in isolation. So, it was G n, G bracket n is equal to W I wrote, no P. So, they do not pay any attention to prices. They look at the company salary that they are offering, they accept the job. They do not look at the price. If another company pays you more, you go for that company. Simple, which is also something we do. It is not very unrealistic. We do not always pay attention to prices. But the question is, if that is true, why is it so? Why did he assume that? Well, there has to be a justification. One is it's common sense, it's often practiced, you can say, in a country. The other thing that I found out while teaching you, telling you the stories in the previous class, is that in an economy when there is surplus labor, in an economy when you assume an institutional feature regarding wage determination, how wage is determined, not really through labor market adjustments that wage is determined, which I told you that in microeconomics, the first day kind of we learned that there is a demand function, there is a supply function, that is a demand curve and a supply curve, they intersect and we find the equilibrium price. At any point, if there is excess demand or excess supply, price would change and adjust that, so that you reach a point of zero excess demand and zero excess supply. That is, you reach the point of intersection of the demand function and the supply function. There is no excess supply or excess demand there. This kind of a result depends upon complete flexibility of the prices. So, prices would move up and down depending upon the situation and will clear the market, so that there is no excess demand or excess supply. Now, in the labor market, in Keynesian model, we find that assumption is not there. They are saying that the wage rate, money wage rate is constant in the medium run. In this model, money wage rate is constant. That means, if there is excess supply or excess demand, it will not be cleared through money wage flexibility. It is not there, it is rigid. All right? Okay. Now, how is it so? Is that a realistic assumption? If that is a realistic assumption that the money wage is fixed, then you can have a labor supply function where money wage is the only variable that enters, P does not enter, because P is not important to people anymore. You take that wage, you like it or not, you take the job. If you do not like the wage, do not take it. Do not accept the work. Seems to be. So, the money wage rigidity, now there were various theories about, various articles have been written, so many things have been discussed. In very simple terms, workers, you can assume a world where workers have an union which represents the worker. The company also sends some representatives like the CEO, the managing director or whoever. They all can meet at some place and negotiate a wage. When they negotiate, they take into consideration what the prices have been since the last wage rate was negotiated, how much prices have gone up, what was the inflation in the country, what kind of inflation they may be expecting in the coming years, because once it has been negotiated and fixed, it's fixed. Nobody can change it until the next revision comes, which may be a year later, which may be 2 years later, which may be 6 months later, I do not know. So, now during that period of negotiation, when the contract is being written as to between the workers and the company as to what the wage is going to be, they may take into consideration prices. In fact, one would do. If my wage was set in 2006, now it is 2012 and I am sitting for a negotiation of what my wage should be, I would be looking at the inflation, I would be looking at other things, how much I work, whether my productivity, my contribution to IIT Kanpur has gone up or not. Depending upon that, I will ask a wage, which I think will be just, and the company would bargain with me, and then the wage will be settled. But once it is settled, it is fixed. So, if you assume, if you accept a world like that, which is quite true, that these are contractual agreements between unions and the firm, and kind of a wage is set there, then this is okay assumption in the Keynesian model that the wage, money wage, W is fixed. And also we are going to assume a surplus labor situation. So, it is fixed, diagrammatically speaking, above the equilibrium point, because above the equilibrium point in the labor market, where labor demand and labor supply intersect, if there is any wage fixed, then you have surplus labor, excess supply will be there, all right. So, let us go back now to the algebraic equation. I have drawn the supply function, aggregate supply function, given the production function and the labor market in the Keynesian model. What I couldn't conclude was the slope of the supply function. So, we need to go into the slope of the supply function, all right. So, I am going to rewrite the equations again, the Keynesian supply function. Keynesian supply function. First, you will have the production function. The next equation is the labor demand function, and the last, then you have the last two equations, not two equations, one is an equation and the other one I assumed W is equal to W naught. Now, if there is surplus labor, also there exists surplus labor. So, there is excess supply in the labor market. So, the labor market diagram, if you draw, what I had is the following. The wage rate is here. So, if there is surplus labor, what will the labor supply function determine at W naught? The amount that is supplied. From the point of view of surplus labor, if there is excess supply, if there is surplus labor, excess supply is there, then the short side of the market would determine employment. So, the labor supply function is not very useful except telling you that how much labor is available, which is unemployed, maybe part of it, which you are not using. That is all. It gives you the value, of labor supplied, the labor supply function. At W naught, Gn tells you the number, gives you the amount of labor supplied or available. All right. So, it is not a very useful equation from the point of view of our working with the model. It is not very useful. Second point, this W is equal to W naught, this equation can be removed by putting a W naught value here and a W naught value there, substituting it. So, what we have after substitution and the assumptions, what we now have, we have the production function, and we have the labor demand function is equal to W naught. Nothing else remains as important for us. Nothing else remains as important. Is there anything more important to us? Nothing. This equation and this equation are the two important ones. This one gives you only the number of people available. And if we are not hiring them, so it tells you the number unemployed if we minus or subtract the people employed. What is important is how many people employed will be given by the labor demand function at W naught, which is this one. This is the number of people employed, and this one is simply the number of people supplied. You can call that NS at W is equal to W naught. So the supply side of the Keynesian supply function, the equations of the Keynesian supply function now reduces to only two equations. The rest are not important anymore once you know them, what they are. Now, therefore, from these two equations, we should be able to obtain the aggregate supply function. So, since we have not specified the functional form, a linear function or a nonlinear function, we cannot get the aggregate supply function, which can also be a linear or nonlinear one. All we can do is, I can differentiate this and get the slope of the supply function, which we did with the IS function, LM function, without specifying a functional form. IS function, LM function, then aggregate demand function. I told you what the slope is going to be. So, let us check the slope of this function. So, slope of the aggregate supply function. Totally differentiate this. So, dy is equal to Fn dn, and the second equation will have Fn dp plus p Fn again differentiated. So, Fnn is equal to 0 because dw naught is 0. dw naught is 0. So, it will be equal to 0. Now, from here you can get the, Fnn, nobody said anything, dn is equal to 0. Fnn dn is equal to 0. Now, from the first equation you can get the expression for dn and substitute it there. So, what you have is from this equation dn is equal to dy over Fn, substitute it there, substitute it in this equation. So, what you have is Fn dp plus p Fnn dn will be equal to dy over Fn is equal to 0. Now, the slope will be dp dy. So, dp dy, slope of the function, aggregate supply function, is equal to minus p Fnn divided by Fn square. dp dy is equal to minus p Fnn divided by Fn square. Now, you know Fnn is negative, Fn square is a positive term, p is a positive term. With a minus sign, this is greater than 0. So, this is the positive slope of the aggregate supply function. This is the positive slope that I was talking about, that I diagrammatically obtained in the previous class, is the slope of the aggregate supply function. Now, look at the fun here. Initially, in the Keynesian cross model and in the ISLM model, we assumed a very passive supply function, which is horizontal. Prices were fixed. You remember that? Aggregate supply function was horizontal. prices were fixed, and we said thereby by making that kind of an assumption, we can make the model demand dependent. The supply is no longer playing an active role. It is just lying there. So, depending upon where the demand curve is, output will be determined. The model was entirely demand dependent or demand determined model. Aggregate supply was horizontal and price was fixed, because horizontal line on the y axis the intercept is fixed, and that was the price. Can you look at this supply function when that kind of situation is also possible without telling you the story of excess supply existing in the market or excess capacity existing in the market? So, companies have excess capacity like big classrooms, but hardly any students there, big buildings, hardly any faculty there, big campus hostels, but hardly any students living there. So, if you demand more education from IIT Kanpur, come, there is no problem, there is excess capacity. That kind of a situation I talked about. Can you look at this slope of the supply function? Technically speaking, one assumption can give you a horizontal aggregate supply function. One particular assumption can give you a horizontal aggregate supply function, which is possible technically speaking without getting into these words of excess capacity and all that. Come back to the production function. Y is equal to Fn k naught. The first derivative is Fn. Okay? And the production function I drew was a line like this, Fnn declining. Okay? Look at this function. If Fnn doesn't decline, Fn is constant, what happens to Fnn? 0. A constant differentiated will give you a 0 value. So, you can have a production function which is linear, where Fn, the slope of the production function is Fn, is constant. The slope of a linear line is, or a linear function is constant. A straight line is constant. Do you see that? So, what you are saying is, every time the company hires somebody, gets the same extra output. Fn is constant, marginal product is constant. What is marginal product? When you hire an extra person, what is his contribution? That is the product in terms of output. It's constant. I hire one person, what extra output I get? When I hire the 100th person, I get exactly the same amount contributed to my company's output. So, a technical assumption like a linear production function, where Fn is constant and the production function is not a curve like this, is a straight line. Straight line will give you Fn constant, can render dp dy 0, which is the kind of a thing we assumed initially. But I can tell you now, then you had no idea, and I cannot be talking about the details of a supply function. Only I said, please assume the supply function to be perfectly elastic, what is called in economics. It's a horizontal line with 0 slope. But you can see what kind of an assumption will give you that. Is it clear? Clear? Everybody? Acha. So, now you can appreciate these points, because you have matured now over the weeks. You know more macroeconomics. You know what the stories are, what the algebra behind these kind of a story. So, now you can appreciate that. Okay. Now, let us go over to something else, the complete Keynesian model. The demand side, if you recall, the demand side has the IS and LM equations. So, you have the IS equation, which is y is equal to A naught plus C into 1 minus Ty plus IR. The LM equation, you have M naught. Now, write not P naught, We are not in a fixed price model anymore. Price will be a variable. Aggregate supply function is upward sloping. So, m naught over p, not p naught anymore, is equal to h y plus L r. This you already know, all right. Okay. Then on the supply side, which I just, there are two more equations. One is the production function. The production function is y is equal to f n k naught, and the other one was the labor demand function. Labor demand function. What will be the labor demand function? It will be P f n is equal to W naught. I said two equations are sufficient to consider. The other ones can go through substitution, and the labor supply function is redundant in some sense. It tells you only the number of people available for work. But with surplus labor, all are not hired. So, there are some unemployed people in the country. So, you essentially have four equations. Call them, if you want, 1, 2, 3, 4. 4 equations. Now, 4 equations in a model will be a determined model if you have 4 unknowns, 4 variables to solve. What are the 4 dependent variables or endogenous variables that will be solved by the model? The 4 variables are y and r from the ISLM, you know that, y and r are measured. But what are the other variables? Now, with the supply side. Yes, yes, you said the right thing. What's your name? You, yeah. You have said the right thing. I can read your lips. P, right. P is one of the variable. And what's the other one? You are mumbling, but you don't have the confidence to say it loudly because you don't have the confidence. You are absolutely right. P is one of the variable now. Price will be determined, and very good, and N. I just saw her lips. She's looking at the board and mumbling, but not saying it loudly. So I encouraged her pushed her to say that. Yes, absolutely right. P is now a variable. It's no longer a fixed price model. Now we have a complete demand supply model where price is a variable. So you can see how prices change in the economy. It's a matured model. It's a complete model. So yes, Y, R, P, and N. And now, if you don't mind, what I would do, I would, from the first 2 equation, I would reduce the 4 equation model into 2 equation model. From the first 2 equation, I would eliminate R. Suppose I ask you the question, tell me what is the main fiscal policy multiplier in this model. Suppose I ask you the question, which I have been asking you right throughout. What is dy dg in this model? How would you solve? The best thing is differentiate these 2, eliminate dr, and differentiate these 2 and eliminate dn. Then r and n gone, we now have y and p to be determined. So do that. Let's do it. So what you would have from 1 and 2, you get dy is equal to dg is equal to dg plus c into 1 minus t dy plus ir dr. The second equation will be, let's assume money supply constant for the time being. We will consider the monetary policy multiplier later, dy dm. So it will be m naught over p square minus dp. Am I correct? If you differentiate p, minus m naught over p square dp is equal to h dy plus LR dr. Now you can see, you can get a dr value here. So the dr value would be minus bracket m naught over p square dp minus h dy divided by LR. Put that number in this dr. So what you have is dy is equal to dg plus c into 1 minus t dy, then minus this bracketed term which is m naught over p square dp and minus h dy bracket close, you will have IR over LR. गड़बड़ किया है, प्लस होगा ये, plus. So this kind of a thing you will get. Call this I can rearrange the terms here. I will get, if I club the dy terms, then I will have 1 minus c into 1 minus t, then minus, it will be plus h IR divided by LR dy, and that minus p into that can come on the left hand side. It's an endogenous variable price. I'm bringing all the endogenous variables to the left. So it will be plus m naught IR divided by p square LR dp is equal to, the only thing that remains is dg. Only thing that remains is dg. Call this equation number 5. Call this equation number 5. Now from 3 and 4 we have we have dy is equal to fn dn and fn dp, then plus p fnn dp dn is equal to 0. From this equation we have dn is equal to dy over fn. Substitute it there, then you have fn dp plus p fnn over fn into dy is equal to 0. Call this equation 6. Find out if this 2 algebra is okay or not. Call equation that one 6. Now I have 2 equations only, 5 and 6. I have eliminated dr through substitution, I have eliminated dn through substitution. So I have 2 equations and 2 unknowns are there, dp and dy. Okay. Now copy it down, then I would tell you from now onwards I would be using matrix algebra to solve, because the next few topics, at least one topic would require a lot of matrix algebra, Cramer's rule, to solve to get the multipliers. Instead of through substitution, it gets messy. Cramer's rule use karo, use Cramer's rule, matrices, set them up. It's very nice and easy to solve them. So if you have copied it down, once you have copied the equations down, what I would do, and this is the method I will keep till the last topic, life is much simpler. to get these equations solved, these multipliers, not equations, to get the multipliers, to obtain the multipliers, we can just use these equations, 5 and 6. So what I have from 5 and 6, if I club and make two columns, one for the dy column, one for the dp column, then from the first equation, the dy column has 1 minus c into 1 minus t plus IR H over LR. This is the dy column. The second column will be the dp. What is the dp term? M naught IR over PLR from the first equation, 5. I have p square there, okay, p square. From the second equation, dy column has p fnn over fn, I think, p fnn over fn, and dp column has fn. So this is my matrix, which is multiplied by this column vector dy dp. This is how you can use matrix to write the equations. So what you are saying is this first row is multiplied with this column. The first element is this first element here, plus the second element into second element. For the second equation, again this row is multiplied with this column vector. So first element and dy plus this with the second element here. That's what you do. And what I'm looking for is the multiplier, which is one lone variable here, that is in the first equation, exogenous variable. All exogenous variables are written on the right hand side. So the exogenous variable here is dg. So if I have a dg column here, dg has one value there in the first equation. The second equation, there is no dg variable. So it will take a 0 value. So the column vector here would be 1, 0 for dg. So this is the method I will be using now till the last topic. It's easier to solve. In fact, you could have had the 4 equations right away in the matrix, but to work with 4 columns, 2 columns, but 4 rows is much more cumbersome. So I eliminated, simplified the system into 2 equations. Now with 2 equations, 2 by 2 matrix is much better. 2 by 2 matrix is much better. All right. So now what I have here is that you know how dy dg will be solved. Well, dy dg will be the determinant of the matrix with dy, since I am looking for dy dg, dy column will be replaced by 1, 0. So it will be, I am using the straight line for determinant, 1, 0, the second element will remain, dy column will be replaced by the dg column vector, the second column here would remain as it is, which is m naught IR divided by p square LR, and the second one here is Fn. So that's the determinant of the in the top, and divided by a determinant of the entire matrix, which is 1 minus c into 1 minus t plus IR H over LR, and you have m naught that's the determinant of the entire matrix. Now, you can find out the determinant right away. You know how to get it. 1 multiplied by this, diagonal terms are multiplied, minus the off diagonal terms product. That's the determinant. The product of the diagonal terms minus the off diagonal terms. So it will be Fn minus 0 into that is 0. Wonderful. Nothing to be done there. Divided by complication, Fn into this, Fn into 1 minus C into 1 minus T plus IR H over LR minus Pfnn Fn into that. P, my goodness, it is mess, minus Pfnn divided by Fn into m naught IR m naught IR over P square LR. Two terms. So this is your dy dg. Now we need a better life. Let's simplify and make it comparable with the other multipliers that we have seen. The dy dg in the previous case. Dy dg in the previous case. You can see one thing, you can divide numerator denominator by Fn. Cancels out. 1 will be there, which is great news. Earlier dy dg used to have 1 in the numerator, so let 1 be there. And here, when you divide by Fn, it becomes Fn square, no? It becomes Fn square. So what you have, therefore, dy dg is equal to 1 divided by, wonderful, 1 minus C into 1 minus T plus IR H over LR, ठीक है? And here minus Pfnn over Fn square into m naught IR divided by P square LR. Now you can see one thing here, Pfnn over Fn square, what was that? You just had this expression today morning, the slope of the aggregate supply function. Slope of the aggregate supply function. It is visibly there. This is the old multiplier. 1 over 1 minus C into 1 minus ISLM multiplier. 1 over 1 minus C into 1 minus T plus IR H over LR. ISLM multiplier. Now, minus a bunch of terms. Is it a positive term or a negative term? This is positive. IR, LR both are negative. So, this ratio is positive. Here is a negative, but with a minus sign is. So, entire thing is a positive. So, what you are saying is quite disturbing now. With the Keynesian cross model to ISLM, the multiplier weakened. With now complete Keynesian model, the multiplier has weakened further because you add a positive term to the denominator. So, the ratio value falls. So, the multiplier is becoming more and more weak. The expenditure multiplier, the more you make the model realistic with price changing, etc., we have to find out why it has become weak. We will find that out diagrammatically, the intuition. But just by looking at the algebra, if we want to compare this, it's very clear that if you compare them, the expenditure multiplier has become even weaker with the supply function, the complete Keynesian model, because something is happening. We got to check that with price movements basically. Why is price movements making things weaker? We have to find out. Achha. Now, this is the slope of the demand function. M naught IR over P square LR, what was the slope of the aggregate demand function in the previous class I had? I just want to check that. What was the slope of the aggregate demand function? From IS and LM you get the aggregate demand function. क्या है aggregate demand function का slope? Huh? 1 minus C into 1 minus T divided by I minus IR this term divided by this term. This term divided by inverse of this. Inverse of this. No, this is this. It's very funny. So the demand function slope is not directly there. Parts of there separated from each other, lying there, but not together. But the supply function slope is intact. This is the aggregate supply function slope. That's intact there. And this whole thing is a positive number. This whole thing, this entire thing with the minus sign is greater than 0. So the fiscal policy multiplier or expenditure multiplier has become weaker. The strength has gone down. So we need to find out why is the strength gone down. Now you notice one thing I just said, that you get an horizontal aggregate supply function if f and n is 0, f double n is 0. I was telling you the technical assumption can give you that. If f and n is 0, this whole term is 0. You're back to the old multiplier ISLM. You see that? You're back to the old multiplier, ISLM multiplier, 1 over the first term. Second term hai nahi, which I was trying to tell you a few minutes back. So you get those results. It's consistent what I'm doing. What I told you, the stories are consistent. Now we are reaching 55 minutes mark. So roughly the end of one class. So what I plan to do, before I give you the intuition behind why the multiplier is becoming weak, I need a diagram. So why is the multiplier getting weaker or is weak compared to the previous multiplier, the previous model? I need a diagram to talk about that. I would consider only two diagrams. I won't complicate life. I would take the ISLM diagram and I will take the aggregate supply, aggregate demand diagram. Two parts. So first is the ISLM diagram, and underneath I will have the aggregate demand, aggregate supply diagram. Suppose the demand function is like this, aggregate demand. Suppose the supply function is like this, aggregate supply. And this equilibrium point corresponds to also equilibrium in the demand side. So this is IS and suppose this is LM. And this is a rate of interest. Some LM has a money supply and a price initially say P naught. That means this is the price P naught and this is the output level in the economy which is demanded and supplied Y naught. So you are at the intersection of IS and M, because on the demand curve it always means you are at the intersection of IS and LM, because IS LM together gives you demand curve. So every point on the demand curve is an equilibrium point in the IS LM diagram, because you require both the equations to get the demand function. And suppose this is the supply function, and if you draw the labor market, there is a labor demand function and a production function and all that. I am not drawing them. I am just drawing these two diagrams. Now, this is the story. Suppose there is a government expenditure increase according to the ISLM model. According to the ISLM model, the IS curve will shift, a new equilibrium point will come of ISLM intersection. Remember that? That means the new point should correspond to a demand function. The question is, where is the demand function? So the demand function must be shifting, because prices are constant. So if IS shifts because of a government expenditure increase, then this point, and since prices have not changed, is the new point on the demand curve, but there is no demand curve. So essentially what he's saying is that prices have not changed. Look, LM is the same LM. LM has prices. If prices change, LM will shift. So prices are not changing. So the new point on the ISLM corresponds to a new point on a demand curve which doesn't exist. That means the new demand curve is somewhere there. And if you remember the aggregate demand slope, if G increases, aggregate demand shifts parallelly. So you have a parallel shift in the demand function. Call that AD1. Parallel shift in the demand function called AD1. This is, say, AD naught, AD1 and AD naught. So that's the new demand function. So when demand increases, what is happening? The story is that the firms are running down inventories to meet the extra demand. In the aggregate demand, this line, by the way, hasn't been much of a parallel line. Probably now it is a parallel line. This original equilibrium point and this new point, which corresponds to the ISLM intersection, this new point which corresponds to the ISLM intersection, is creating a excess demand for goods. The potential demand is creating excess demand for goods, which is equal to this gap, because the supply line is here. So the actual supply in the economy is here, but the potential demand has gone up to that point. This is what I'm trying to say now. With IS and LM intersection, when you reach, suppose the economy has met that through inventory adjustments, actual output hasn't increased. So the potential demand has gone there, which will restore equilibrium here, but the supply is still here. There's an excess demand. You can call these points, you can call this, say this one is called maybe E1, and this one can be called E2. So E1, E2 minus E1 is equal to excess demand for goods. E2 minus E1 is the excess demand for goods. All right? When in a market, which we teach in microeconomics, there is excess demand, there is upward pressure on prices because of the potential demand. So now prices start increasing, and according to microeconomic theory, we know as prices increase, companies have an incentive to supply more. All right? So the question is, how do prices increase? One theory says as prices increase, all right, the LM curve will start shifting backwards, because LM is m over fixed m over p. As p increases, the left hand side value of m over p falls. So the right hand side can fall also, and what happens is that that adjustment comes through rate of interest increase, speculative demand falling, etc. So as it increases, prices increase, you can say along the demand curve, the prices start moving upwards. Along the demand curve, the prices start moving upwards, and the LM curve starts shifting backwards. Point is, where will it reach the new equilibrium? The new equilibrium is reached at the intersection of the supply and the new demand. So the LM curve will shift backwards till it reaches equilibrium in the ISLM diagram somewhere on the new IS and a new LM that will emerge, which also will be a parallel shift in the LM. Call that maybe some LM1 it will finally go to, where prices in the economy would have risen to P1 and output will also increase, but it will only increase up to Y1, and this is the new point of equilibrium where you have m naught value of money supply divided by P1 value of prices. So the adjustment goes up along the demand curve, economy starts adjusting. The final level of output that the economy produces is Y1. So in a normal ISLM, we would have come to the green point. But with price increase and a backward shift, leftward shift in LM reduces output farther, reduces demand farther. So the multiplier is essentially becoming very weak. That's why the multiplier is weak. This output level, this green line is the ISLM result. But we come to the pink line, which is the complete Keynesian model with price flexibility. So price increase reduces demand in the economy, reduces output in the economy also. If demand falls, why would companies produce more? Companies would produce less. So you see why the multiplier is weaker. Because from white to pink, the distance, that distance is less than from white to green. White to green was the distance under ISLM, which was 1 over 1 minus C into 1 minus T plus IRH over LR. Now that last component addition in the denominator of the multiplier is essentially saying that the multiplier has weakened, which is you go up to the pink point, Y1. So why the multiplier has become weaker, you can see. Excess demand increases prices and reduces demand. So that's why people say inflation is bad for the country. Because what inflation does, it ruins purchasing power, people buy less, companies also produce less. Isn't it? Here is a gradual upward shift in prices and it stops. Inflation, of course, is a dynamic variable because prices continuously rise. All right. That's why people say inflation is bad, because what inflation does is that it lowers your purchasing power, you demand less, excuse me, मेरा throat तो गया. Your purchasing power erodes and you buy less. And the companies also produce less. The economy produces less. So now do you see this multiplier, expenditure multiplier, why it has become weak? You see that? All right. This, yes. गलती किया? What? Yeah. P1 is with the ace and the green AD1. No. E1 is the white point. Let me use white chalk. E1. Let's use the green chalk there. E2. And let's use the pink chalk there. This one. E3. Now is it clear? Becoming a perfectionist in diagram. I will start painting soon after course ends. Abhi theek hai? Clear? So price increase is the culprit. And you can also say, sir, tell us more, why price increase is a culprit? Well, when prices increase, then for money market equilibrium, since the left hand side of LM equation has value falls, the right hand side should fall to match, and the right hand falls through rate of interest increase. Now, when rate of interest increases, private investment cannot increase through the potential. So there is a crowding out through the back door coming. One crowding out is there for rate of interest increase and IS shift. Another crowding out coming with LM backward shifting and increasing rate of interest even further, which is an indirect crowding out coming into the picture. Look at the ISLM diagram. First crowding out from this point to that point, from this point to the green point. We learned this crowding out. This is the rate of interest, which is say R naught, and this would have been the rate of interest, which is something, say R prime naught. Now, with LM shifting, there is even higher interest rate, which goes up further. So the rate of interest increases even further to R1. So there is a double crowding out. First crowding out is from R0 to R1. Then the next crowding out is coming through an indirect effect by prices increase and money market adjustments, that you go to R prime naught to R1. So the full potential of the expansionary fiscal policy cannot be realized, because there are two rounds of at least crowding out. One direct, the IS shift, which we learned in the ISLM model. Now a second round coming from the prices increasing and money market adjustments, which requires further increase in real rate of interest. So the multiplier, which is like I'm trying to run my full potential. First, I get a hurdle on the floor, something stops me, the floor is not even. Then there is a strong wind from the opposite direction, which slows me farther down. So I run slowly, I do go a distance, but that's not my full potential. Without those uneven surface and the strong wind coming from the opposite direction, I can run much faster and reach a longer distance. But I cannot. Two rounds of crowding out going on. Do you see that? All right. Now the algebraic part of monetary policy multiplier, you can work it out yourself. dydm, you can do that. But what happened in diagrammatically is a very similar situation in case of money supply multiplier. Let's check that out. dydm. dydm. You can find out the multiplier itself using algebra But diagrammatically what is happening, I would draw the ISLM diagram again. This is the initial points, equilibrium points. Now, let's talk about money supply multiplier. What happens? What was the color? I was using the green color. Okay. The money multiplier will now, monetary policy, expansionary monetary policy, will shift LM out. So, you will get an LM curve like this, a parallel shift. Parallel shift in the LM. All right. So, you have M1, but prices are the same. M1 increased, M1 is greater than M0. So, the aggregate demand curve will shift at the same price. It will be same kind of a logic. It will be somewhere here, because the demand curve will always have the intersection of IS and LM, because those two equations are used to get the demand curve. So, the aggregate demand curve will shift, not parallelly probably, anyway you can find that out, AD1. Now, excess demand is created again. Output is at Y0, demand has gone there, prices will start increasing. When prices start increasing, along the demand curve, prices are increasing along the demand curve, LM will start shifting backwards. M1 is there, increased value, but P1 now increases, P. So, ratio falls, it starts shifting backwards, and it will reach a new equilibrium, which is some LM2, which will have some M1 divided by some new price P1. This is LM2. It will shift backwards. So, first the green line shifted LM here, then it is going backwards. It's moving backwards. The LM curve is moving backwards, and where you have a higher level of price now, P1, and of course some higher level of output, Y1, and you don't have the full potential of the output up to green line. You don't have the green line potential. The green line potential would have been possible if you had a fixed price model where aggregate supply is horizontal. But since prices are increasing, LM will go out, then come back a little bit. So, if you work the algebra of dy dm, the way I got dy dg, you will see that multiplier is weaker compared to the dy dm multiplier under this multiplier is weaker. It clearly says that, because prices would increase. As prices increase, you can see the gap between demand and supply shrinks. करते करते एकदम बंद हो गया, zero हो गया. देखा? The gap is this much initially. As prices increase, it eliminates excess demand, and with price increase, supply also increases along the supply line, and then they meet here at the pink point where there is zero excess demand. Equilibrium has been reached. And you will see dy dm multiplier in this case is less than the dy dm multiplier we obtained algebraically also in the ISLM model. That value is less. You can check that out yourself. This is a little bit of homework you can do. What is the dy dm algebra? Using matrix algebra, you can do that. You have to differentiate dm also. There will be a dm component, which will be dm will be multiplied by 1 over p, which you keep on the right hand side, and also dp differentiation will be there, and you can get dy dm. So the money supply multiplier also becomes weaker. So it's just not fiscal policy is now weaker, monetary policies also has become weak compared to the ISLM model where prices were fixed. So none of the policies are really working. None of the policies are working if prices are increasing. If your price is fixed, then it's all right. But if prices are increasing, none of them are really working. Okay? So a better situation would be if prices are increasing continuously, you have a supply curve based policy. If the supply curve can shift, it can counter prices, increase output also. If supply can shift as opposed to demand shifting, if supply can shift, it counters inflation, puts downward pressure on prices, as well as output will increase. Demand management policies become weaker if you have prices increasing. So in India today, or the past year or so, we are having strong inflation. And Government of India and Monetary and RBI, what they have been trying is reducing money supply and control inflation. Reducing money supply means shifting LM not out, but shifting LM backwards in some sense, so that aggregate demand shifts backwards and try to control prices. They have not been able to do that much, but that has a danger of output falling, which is happening. A better policy would have been for us through a supply management. If supply curves can be shifted out instead of monetary management by contraction in monetary policy, which is LM shifting backwards, the danger is, yes, prices will have a tendency to come down, inflation has come down, but that's the cost of output. And in India today, the growth rate falling, industrial output falling, all that happening. This model explains that or gives a feeling for that quite well. But this is what you would expect if RBI or government has contraction in monetary policy as a tool to control inflation. But we don't have inflation here. We have static model. Prices goes up in steps and stops. But in a dynamic model, but this gives you the feel that when prices are going up continuously, what will happen? So the policies are still they are pursuing it, very adamant. They are incorrect policies, completely incorrect policies, right from the beginning. In the recession, in fact, they now brought a severe recession into the economy, which wouldn't have come. Not so much. Some dampening would have been there from the external sector, but not so much. To be honest with you, Keynesian model is nearly over. But I want to ask you a few things, a few questions before I close it. Look at the look at the labor market diagram. Wage rate there. Look at the diagram you had. Wage rate fixed, labor demand, labor supply, and aggregate supply function. I drew the aggregate supply function, previous day's class. Aggregate supply function, when diagrammatically I drew that. Do you have that diagram with you? All right. Now you tell me, if there is an upward revision in wages, what will happen? upward revision in wages, what will happen? I am quizzing you a little bit. If there is an upward revision in wages, look at the diagram. W line goes up from W0 to an above and higher line, say W1, lying above W0. All right? What will happen? What is the effect that you will have immediately in the economy? What's the thing you will have in the economy? Output will fall, aggregate supply function will shift to the left. Do you see that? Aggregate supply function will shift to the left. Okay? In this model, you can obtain a dy dw if you want, which I put dw is equal to 0 in the supply function. You can have dw non-zero and can solve dy dw, no problem, and you will get a result there, negative result, inverse result. It should be negative. W goes up, output falls. Acha. Another question I am asking you, suppose there is a technological improvement, massive technological improvement came through, then marginal product line will shift to the right, W remains the same, and aggregate supply will shift to the right. Right? Now, in the ISLM, in the aggregate demand, if aggregate supply shifts to the right, what will happen to prices in the economy? What will happen? Go up or down? Down. Now, money wages are fixed. So, what happens to real wage? Real wages increase. You see, now you can use your mind and the model to talk about many, many important things. With the speak on TV, sometimes it doesn't make any sense, but now it will make some sense to you. The real wages in the economy go up, which every economy wants. Real wage means real income. So I can buy more goods. Not just tell me I have 1,000 rupees more, but I want my real income to go up, so that I can buy more goods, more domino trips, which my children would love. That's what they want, real expenditure to go up. Well, they want many things which is not possible, but usually that's what people love. Everybody likes, economists like, people like real income to go up. Now you see these things, you can connect them. So to be honest with you, maybe I'm 10-15 minutes short, but I have nearly come to the end of the discussion of the Keynesian model. My point is, whether I would, there is a topic, I call that a supply side model. It's a very simple model, a supply side model. Whether I will discuss that or not, I haven't decided yet. So I may skip that. I will go to the exchange rate systems, if you see in our topics, balance of payments account, then the last model, algebraic model, to deal with open economy issues. I will do that in the next period. You don't mind if I close today, it's all right.